session at the end, and of course always please wait for the microphone because we got folks in overflow that won't hear if you don't use the microphone, and we won't get the recording if you don't use the microphone. So you got to use the microphone is the message that I'm trying to get across here. Teachers, if you're in the audience, welcome, of course. We have a sign-in sheet for you at the front desk along with the professional development certificate. Any students here that need some kind of proof that they came, we've been hearing that. There'll be some certificates at the front as well, but you can't get it until afterwards. I was once a student too. So we'll have those for you as well. If this is your first time here, welcome, and we hope you come back for more. There's a sign-up sheet by our front doors. You can add your email address to that, and we'll send you emails to keep you updated. And we don't send them out like every week, so you're not going to get inundated by them, but we like to think we send them out at a good pace to keep you informed. So without any more, really, I'm going to sit down. I want to bring down Dr. Matthew Bering from Rice University. He's an astronomy professor there, and he's going to tell us more about tonight's speaker.
Okay. Well, it's a pleasure to be here. It's my first time here at an LPI talk, so I'm excited about it. And I'm going to ask you a question to start off, and that is, who in the audience has actually met an alien?
Terrestrial or alien?
I said an alien. Okay? An alien, okay. My hand's only halfway raised because, you know, I will run into somebody in the street and they'll say, I think the Astros are going to win 100 games this season. They qualify, in my opinion, okay? Okay, so I started life out in the US as a resident alien, but that doesn't qualify. Okay. However, I admit that my wife has. Okay, so my wife, when I am errant, when I'm not behaving myself, as happens all too often, she will come sometimes look at me, stare me in the eye, and look at me and say, "Who are you, and what have you done with my husband?" and I know, I know to get my act together. Okay, I do not work in ET research. I am a high-energy astrophysicist, but one of the fields I do work in on pulsars are the first discovery of radio pulsars, pulsating neutron stars, condensed stars. The discovery in 1967 that led to the Nobel Prize in Physics for that, when they got their first signal in Cambridge, Jocelyn Bell and Tony Hewish, they first looked at it and they worried that it might be a signal of extraterrestrial life. It was going blip, 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 blip at a fraction of a second. And so astronomers have to think about these things. I'm not an expert in that. I'm an expert in pulsars, but not in the study of extraterrestrial signals of other sorts, which is the subject of tonight's talk. I'm very excited about it. We're going to the expert here. So Dr. Szostak got his PhD at Caltech after doing his undergraduate degree at Princeton a long time back, and he had an extended period stay over in Groningen, was in the Netherlands, right? Working research in various areas. You were working in galaxies, radio galaxies, is that correct? That's a big field, rotation curves, understanding the origins of what produces how you get high velocity gas clouds in the outer regions of galaxies, which is underpinning our understanding of dark matter in the universe. It's a big question in the universe. He has had various lives, various careers throughout. He's been based in the Bay Area for a long time. You've had startups, right? In the technological, in the computer sector, in the software sector, and things like that. He's an expert advisor to movies, a number of them. It's very impressive. He's regaled us at dinner about how he's been involved in with script writers, with stars in movies. And the thing that impressed me most is he's met John Cleese. So here we go. We've got a true star here. So without further ado, I mean, he is an expert. He's been at the SETI Institute since what? For over a decade. And he's going to tell us about ET. I thought when I first thought ET means exceptionally talented. We apply it to students at Rice. So this is a different sort of ET, I just want you to know. And we're very privileged to have him come and tell us about what's out there, what could be out there. And without further ado, here we have Dr. Seth.
Thank you very much, Matthew, and also Andy Shaner for inviting me here to have the eyes of Texas upon me. I was going to warn you not to applaud before you hear my talk, because you'll only regret the applause later. How many of you think that there are intelligent beings out there to be found? Okay, I'm not going to count you. How many of you think, no, probably not? I'm surprised you've come this evening. You are, of course, the people that I would like to talk to afterwards. I'd like to find out why you think that. I will say a little bit about why we think they're out there. This is largely a speculative talk. We're doing the experiment, but the experiments have not turned up ET yet. I get this all the time at parties. People say when they find out what I do, because I usually don't tell them what I do for a living. I usually say I'm in transmission repair or something like that. But if they do find out, they'll often ask, so have you found them yet? Which I find a peculiar question, because obviously if we had, I'd be in Stockholm collecting a big check. But then the next question is always, are you close? Which is a very interesting question. And how do you know if you're close? It's like pregnancy. How do you know you're close? You don't know you're close. So in any case, I'm going to tell you a little bit about why we think they're out there. As I say, it's somewhat speculative because we haven't found them. How we're looking, some of that, where I think we ought to look. And then the second half or the last third of the talk will be what the reaction to that would be. Because a lot of people are rather interested in knowing, well, okay, but what if you succeed? How does that affect me, the car buyer? So I'm going to tell you a little bit about that. So that should all be wrapped up by 11:40 or something. And then we'll just, then you can grill me like a mess of onions on the Barbie, whatever. Okay, so the fundamental fact about why we think that they're out there, not all of you, but why, and when I say we, the people at the SETI Institute, obviously where I work, but also I would think 9 out of 10 astronomers would agree with the majority opinion here that there's probably somebody out there, is that the universe is very vast. You've all seen, this is one of the Hubble Deep Field photos. Those are all galaxies there. And this is a very tiny bit of the heavens. The number of stars that are accessible to our telescopes is a 1 followed by 22 zeros. That's a very big number. That's a very big number. But of course, life isn't going to, form on a star. How many of those stars have planets? Now, when I was a kid, just before the Crimean War broke out, I would go to the Hayden Planetarium in New York, and they would frequently tell you that this is probably the only planetary system in the entire galaxy, the one we're in, because making planets was a chance occurrence, an encounter between two stars. That was a popular theory for a while. If that's the case, then there's not going to be any cosmic company out there because there are very few planets. But of course, now we know that's not true. We do know that most of the stars in the universe have planets. If you talk to somebody like Jeff Marcy, who looked for planets, and you say, well, Jeff, what fraction of stars do you think actually have planets? If you had perfect instruments, what fraction would show planets? Say, I don't know, 70%, 80%. Okay. In astronomy, 70 or 80% is the same as all. Right. In astronomy, pi is equal to 1. In astronomy, I say, don't have an astronomer do your taxes, because they'll get it right within a factor of 2 and consider that pretty good. Okay, so that means the number of planets, since planets come in bunches usually, you don't just get one, the number of planets is maybe 10 times that number at the top. That's a lot. And that means just in our Milky Way, they're on the order of 1 trillion planets. Okay, now, most of those planets might be worthless in the sense that Mercury or Neptune or whatever are somewhat worthless, not big in your life. But on the other hand, when you buy 1 trillion lottery tickets, they're not all losers. That would be very special. Okay, so for the half dozen of you in this audience tonight who think that this is the only place where anything interesting is happening in all this universe, just the part of the universe we can see, everybody else should admire those people, because that's a very audacious point of view. Those people believe in miracles, that you are a miracle. Okay, and I know you like to think you're a miracle because your mom told you you were a miracle, but it may not be true. Okay, one of the questions is, all right, so we now know that a lot of these stars have planets, but what fraction of those planets really are amenable to life? And that was really the basis of launching this instrument, the Kepler Space Telescope, launched by NASA about 4 years ago. And the intention there, the mission, should it choose to accept it, the mission of the Kepler Space Telescope was to find out what fraction of stars like the Sun have planets that could be like the Earth. In other words, what fraction of Sun-like stars have Earth's cousins orbiting them? And the jury's still out on that. The data are still coming in. We may get better numbers, but here are some numbers that came out just a couple of months ago. something like 1 in 5 sun-like stars may have a planet where you could have liquid oceans, atmospheres, and so forth. That's a very high percentage. I mean, it could have been 1 in a million. Right? It could have been 1 in 1,000. It looks like it's maybe 1 in 5. Most stars are actually not like the sun. Most stars are much smaller. They're called red dwarfs. 3/4 of all stars are red dwarfs. And these are just sort of dim bulbs, kind of like my brother's. Red dwarfs are very plentiful. You don't see them with your eye because your eye tends to see the stars that are the brightest stars when you go out at night, if you can see the stars from Clear Lake. Despite the name, maybe you can. I don't know. But in any case, you won't see too many of the red dwarfs because they're very dim. They're very dim. But there are a lot of them. And it turns out that somewhere between 16%, that's maybe a lower limit, and up to 50-some% of the red dwarf stars have a habitable Earth-sized planet. So the number of cousins of the Earth just in our galaxy is on the order of tens of billions, okay? And if you don't like our galaxy, if our galaxy is not up to your demanding needs for a galaxy, that's okay. We can photograph 150 billion other galaxies and, you know, perhaps you want to move. Okay, so there's that. Here's another fact for your fact file. This is just a little bit of rock in northwest Australia. It's a photo I made about 10 years ago. And you can see, you know, the size of it. But you may also notice, can you see those things that look like sort of fossilized cauliflowers in this rock? This rock's very old. This rock's 3.5 billion years old. And that number, by the way, is known to about 2%. That's, you know, radioactive dating. But these things are not cauliflowers. Those little round things are bacterial colonies, what are called stromatolites. Remember, the Earth's only 4.5 billion years old, so this was 1 billion years after the birth of the Earth. The Earth was still a kid, and it already had life all over the place, enough to fossilize just about anywhere you looked. Okay, so that suggests, it certainly doesn't prove it, but it does suggest that life was not a very improbable thing. It sprung up very quickly on the Earth, right? Essentially, once the Earth could support life, there was life. It doesn't sound like it was a hard thing to get going. Okay. Now, it doesn't prove it, as I say. I mean, if you walk into a Las Vegas casino, you put a quarter in the machine, and $10,000 comes out, you could say, well, Marge, that was an easy bet. It might have been an easy bet, or it might have been that you were incredibly lucky. So maybe we're incredibly lucky, but this is suggestive. Okay, so where should we look for life? Well, you know, you read stories in the paper about some new discovery of a planet somewhere, or maybe water on Mars for the 427th time, or whatever. And it's easy to sort of lose sight of the fact that many of these stories relate to life, because that's what you're interested in. Rather fewer of you are probably interested in the question of the hydrological history of Mars, although, you know, we do look at that. In this building, they look at that. Okay, but to the extent that it's about life, all these stories are really just 3 stories. There's a 3-way horse race to try and find life elsewhere in the cosmos. I think that they all have about an equal chance of crossing the finish line first. So just to enumerate them very briefly, the first horse, just find it nearby. Do what they do on television. Just build a rocket and go look for it. Okay, and of course we do that. In fact, that's where the big money is. I mean, we can't go very far. We can't go to the next star system. We can't call up Scotty and tell him to put the pedal to the metal or anything like that. But we can go to Mars, Jupiter, Saturn, and there are at least a half dozen worlds nearby where there could be life because there's some sort of liquid there. Mars, everybody knows about Mars, everyone's favorite inhabited planet. There are Mars everywhere, books, movies, radio plays. One place there might not be any Martians, might be Mars, but we don't know that. Okay, I think it's still a very good bet. This is just one example of the kind of evidence that's suggestive of life on Mars. There have been claims, and they're controversial, but there are claims that there's some methane gas coming off the surface of Mars, which would be interesting. Methane, I mean, it could be due to cows on Mars, right? Bovine flatulence, or for that matter, porcine flatulence. So, you know, maybe they're pigs in space and they're on Mars. Okay, it could be that, or it could be bacteria. The thing about methane is it can also be produced naturally without any biology being involved at all. I mean, biology is natural, but in this sense, non-biological origins for the methane. The thing is, there's so much ultraviolet light hitting the surface of Mars that if you release a whole bunch of methane, within a couple of 100 years, it's all broken down by the ultraviolet light and it goes away. And yet we still find it. So it's stuff that's been made in the past couple of centuries. And it's somewhat suggestive that if you just dug down in the dirt of Mars, you might find some microbes. Well, that's one way to look. There are plenty of other places to look. This is, you can see these brown stripes here on coming off this crater wall. Those get longer in the Martian summer, and then they get shorter in the winter, as if some ice is melting and producing these wet spots. We don't know that for sure, but it kind of looks that way. And maybe the best way to find life on Mars is just to send some robotic explorer to one of these crater walls and just have it, sort of clamber down there and dig up some of that wet dirt, if that's what it is, and look at it under a microscope. So that's one thing we can do. We can also look at some of these moons of the outer solar system. Here's an artist's impression of a moon of Saturn, Titan, okay? And it's got lakes. It's got big lakes. In fact, here's a real photo, okay, made by radar from the Cassini orbiter. But you can see these lakes. These are, to give you scale, they're about the same size as the Great Lakes here in the United States. So they're big, and they're filled with liquid. It's not water. It's too cold out there. It's, ethane and methane. It's liquid natural gas. It's the same stuff you use to fry up your burgers in the morning or whatever. Okay. And you might say, well, liquid natural gas, is that something that, would spawn life? Well, it's organic chemistry, and maybe it has. Maybe it has. And there have been serious suggestions that NASA should build a robotic ship to go sail on one of these lakes and scoop up some of the liquid and look at it. Okay. So that's looking nearby. The second way to find life, the second horse in this race, is just to use big telescopes to measure the atmosphere of somebody else's planet. Because if you could do that, you might find interesting things in it. Now, here's a graph. And they say every time you show a graph, you lose 10% of the audience. I have 12 of these graphs, so it's going to be okay for you. All right. So these are just spectra. This is just, if you will, the reflected light from 3 nearby planets. Here's Venus, and you can see here's a reflected light, and it has a big absorption band here. That's caused by carbon dioxide. There's a lot of carbon dioxide on Venus. Here's the Earth. It also has a lot of carbon dioxide, and every day more. Okay, but we also have water vapor, and we have oxygen, and so forth. Okay, now that oxygen is pretty interesting. I mean, the water vapor is interesting because it might suggest there are oceans here, but the oxygen suggests there's photosynthesis here, and to some degree there is. Okay, so if you found oxygen in the atmosphere of some other planet, you might say, I don't know what that is, Bob, but it looks like they've got lettuce. I mean, they got plants. They got plants. Here's Mars for comparison. It has a carbon dioxide, but it doesn't have any of the other twos. Okay, so if you build a big enough telescope, you could do this not for nearby worlds like Mars and Venus, but you might be able to do it for a planet around somebody else's star. And how to do this has all been worked out. There have been plans on the drawing boards, and even at the, they've even done some of the engineering to do this for quite some time. There's been no money, no budget. NASA doesn't have enough money to do this. So if somebody would write the check, this horse might cross the finish line, 5, 10 years. I think within 20 years, all these things will happen, or one of them will happen, or some of them will happen. But at this point, it's mostly a matter of the money to build this thing. The James Webb Telescope will have some capability. I mention it because that's sort of a local industry. It will be able to find some of these planets around other stars, get a little bit of light, some photons coming off that planet, and maybe analyze them and find things like oxygen in the atmosphere. So these are the two areas, these are the two horses in the race which get most of the attention and most of the money, but I point out that they are looking for what is undoubtedly going to be microbial life. In other words, the big money is going to look for stupid life, which makes sense because there's undoubtedly a heck of a lot more stupid life in the universe than intelligent life, and that's something I prove to myself every time I walk around my neighborhood. So, but I mean, to be fair, my neighbors fortunately never watch this stuff on YouTube if they did. But to be fair, think of the Earth, right? Up until 500 million years ago, there was nothing that you could see that didn't require a microscope, no individual life forms, right? And then, you had the Cambrian explosion and things got a little more complex. But for the first 4.6 billion years of Earth's history, the first 4 billion years of life's history here, there was no intelligent life. Intelligent life might be, just a little bit of foam on the giant ocean of biology that might appear, might not appear. But on the other hand, intelligent life might do something that you could find. And so that's the third horse to find the intelligent life. And that's, of course, what I'll tell you a little bit about. A half century ago, 1960, this antenna, located in the lovely Deer Creek Valley of West Virginia, is an 85-foot diameter. Well, I am impressed that you're proud. Okay. Whatever. Okay. Hey, Here's Frank. Frank Drake did an experiment in 1916, which he used this antenna in April of 1960. So it's what? I mean, it's 54 years ago, I guess now. And he pointed this antenna in the direction of a couple nearby stars, hoping to eavesdrop on signals that would tell him that they have planets with inhabitants. And he actually did hear a signal, but it turned out to be the U.S. Air Force, and that did not count as intelligence, not extraterrestrial intelligence. So there you go. But Frank still works at the SETI Institute, by the way. He's still doing this. He's a true pioneer, and it's very interesting to work in. I mean, you're used to pioneers here in Texas, but it's very interesting to work in a field where the original pioneer is just down the hall. Okay, so there's Frank. But this idea actually makes sense because you work out the numbers. It's a one-line calculation. And it turns out that even we, 100 years after the invention of radio, we could build transmitters and receivers that would allow you to send bits of information from one star system to another. So this makes sense. Let's listen. Let's try and eavesdrop on their signals. Now, I show this little picture of Antarctic exploration, not only because I kind of like to read about the heroic age of polar exploration, but also to point out something that's a little different about SETI, because sometimes I get in arguments with people, is SETI science? And Michael Crichton said SETI is religion and so forth. My response to that was, if SETI is a religion, we ought to be much better funded than we are. But Crichton wasn't listening to me. But let me say that, when you were in junior high school or middle school, whatever, they may have told you that the way science works is that you have an hypothesis, and then you design an experiment to try and falsify that hypothesis. In other words, prove it wrong. And then you'll know that at least that hypothesis isn't any good. Okay, now that does work for some science. Most science is actually not done that way, but some of it is. But in the case of SETI, there's no way to falsify this. There's no way to prove that the aliens are not out there. Because there's a gazillion ways you could miss finding them, even if they're there, right? The fact that you point your antennas in the direction of some star system and don't hear anything, that doesn't mean they're not there. That may mean you were tuned to the wrong frequency, or you didn't have enough sensitivity, or you weren't listening when they were broadcasting, or many other things. So you can't prove they're not there. However, you could prove that they are there. So this is exploratory science. It's like sitting around in the bars of Europe in 1600, debating, do you think that there might be a continent at the bottom of the globe? Could there be something? And you could have a lot of beer and have a lot of discussion and talk about it forever, but that would never settle the matter. The only way to settle the matter was to put somebody on ships and have them go look. So that's what SETI is. It's just exploration. Okay, well, we use this telescope, the Allen telescope array. Here it is. Paul Allen gave the money to do the research and development and build the first 42 antennas, which is the number of antennas we have here now. This is up in a place called Hat Creek, California, which is, it's not there because of the cuisine. Hat Creek's a very tiny little place, but those mountains in the back shield this area from all the radio interference that otherwise would come from the San Francisco Bay Area. It's a lovely place, actually. This is a real photo. I made this about a year or two ago, and that's really the way it looks. Now, we use this antenna, and we point in the directions of various things that we think, well, there might be some, this is a likely place where you might expect a civilization or something. Trying to hear something, we typically monitor 10 million channels at a go, and usually we step those 10 million channels up the dial, and we'll cover literally billions of channels, gigahertz of frequency. The channels are 1 hertz wide, looking for a signal. Okay, and this is the kind of thing we look for. This is this plot just has a little bit of the radio dial here, low end of the dial, high end of the dial, and then the vertical axis is just time. Now you see a whole bunch of noise from the receivers, but you also see that signal on the left-hand side. I suspect the people in the other room do not get my pointer, so I'll try and describe it. But anyhow, that signal on the left is a real extraterrestrial signal. That's just the kind of thing we're looking for. It's at one spot on the radio dial, just like the local radio stations or TV stations or any other kind of station. It's at one spot on the dial. That's the result of a transmitter. Okay, quasars, pulsars, they're all over the dial. But a transmitter will produce something at one spot on the dial. It's also moving down the dial because of the rotation of the Earth that causes a changing Doppler shift. Now, it is extraterrestrial. Unfortunately, it's not ET. That's the Pioneer 10 spacecraft. Remember that guy? It was sent out to make pictures of Jupiter and then Saturn and the outer planets. And it has that, plaque on it with the nudie cuties on it, upraised hand. A buddy of mine at the University of Washington said, Szostak, that upraised hand is a universal symbol of war. I don't know that that's true. But in any case, That's the signal from that. Now, at the time that we made this observation down in Puerto Rico, using the antenna there, that transmitter was down to maybe 2 or 3 watts, power of a bicycle headlamp. And it was at a distance of maybe 3 times as far as Pluto. Okay, so many billions of miles. And you can see the signal's visible right to your eye. You don't even need any sophisticated computer processing or anything. It's just that, it's dead obvious. So this is just to give you some insight into the fact that radio technology is highly refined. It can find very weak signals across vast distances, and it's not hard to send bits of information via radio from one place to another. This was the antenna we were using to pick that thing up down in Puerto Rico, the Arecibo radio telescope. Here, just a couple of numbers for those propeller heads in the audience who want a couple of numbers to give you some idea of the sensitivity. The most sensitivity we've had for any experiment was using this antenna, and that was its sensitivity, that number at the top. But as an example, suppose there were some Klingons 100 light years away, and they had a similar sized antenna aimed our way, which is an important point, they have to aim it our way. We would hear them if their transmitter power was 100 kilowatts or more. That's not very much. There are probably transmitters in Houston with 100 kilowatts, okay? And certainly, in fact, the Arecibo antenna itself has a radar transmitter with 10 times that power. So, it doesn't take a lot. Now, have we found them? I've already told you that. We have not. No dice. And there are people who make a lot out of that. They say, you know, you guys have been trying for a long time. You haven't found anything. You know, obviously, this is a waste of your time. It's a waste of somebody's money. It's not taxpayer money, by the way. It's just donations. Okay. But obviously, this is a failed experiment. Well, that's wrong, because we haven't looked at very much. We've only looked at a few thousand star systems in a galaxy with a few 100 billion star systems. Okay, so this is like, you know, going to Africa looking for a megafauna with large noses that can pick up peanuts or something, and you land on the coast of Africa and you look at one city block of real estate, and then you say, you know, didn't see any elephants. I guess they're not on the continent. See, that's a premature conclusion. Premature conclusion. Okay, so that's why I think we haven't found it. But fortunately, the experiment is speeding up. I'll get back to that, and I think we will do better. We'll be using, of course, the Allen telescope array for our own experiments. There it is again. And where should we point these things? We do a lot of different experiments, but I'm going to make a plea tonight that we look in the direction of those dim bulbs of the universe, the red dwarf stars. There's the nearest one of those, Proxima Centauri. You can't see it from here. You have to go a little bit farther south, but yeah, maybe you can see it from southern Texas. Anyhow, these stars are small. They only have a few percent of the mass of the sun, and even less the brightness of the sun. They're very low luminosity things. Recently, last week, there was a big story. I suspect most of you may have seen this story. The discovery of the first planet that's more or less the same size as the Earth that could be in the habitable zone of its star. In other words, that it could be at the right distance from its star to maybe have liquid oceans. You know, the planet isn't forever freezing or boiling. Okay, the nifty name of this planet is Kepler 186f. Okay, it's 500 light years away. It was found using the Kepler Space Telescope, hence the name. Who knows what the inhabitants, if there are any, call it. We, by the way, have pointed our antennas in the direction of this thing. We haven't found anything so far, but we'll keep looking. But it's far away. It's far away. 490 light years is pretty far. I might point out that these red dwarfs, they have a relatively small habitable zone, as you can see there down at the bottom. Because if you're going to be in a planet orbiting one of these little dim bulb guys, you've got to be in a pretty tight orbit, otherwise it's going to be freezing cold all the time. And that sounds like there wouldn't be many planets there, but that's wrong. Because planets tend to be more densely packed in the inner regions of a solar system than in the outer regions, right? In our own solar system. Mercury, Venus, Earth, Mars are all in, you know, very tight orbits relative to the outer planets like Jupiter, Saturn, Uranus, and Neptune. So that's okay. But there was another problem with these planets that are very close in. They could get tidally locked. And, you know, that sounds like something that might happen to your house. But what it really is that every time you have one body orbiting another one rather close in, what'll happen is very quickly the orbiting body will get locked into a synchronous kind of rotation where one side is always facing the larger body that it's orbiting, right? You know this has happened for the moon. You look at the moon, it's always the same side. Right? We didn't see the far side until the Russians sent a spacecraft around to that side. And you might think, oh, well, that's just coincidence. It's not coincidence. It had to happen, and it did happen. And that would happen for planets that are very close to a dim star, the kind of planets that might be close enough to get enough warmth to have life. You might say, well, that's going to be bad news, because one side will always be facing the star, so it'll be incredibly hot, and the other side will be in perpetual darkness. It'll get so cold on the back that the atmosphere will just snow out into useless heaps on the ground. So people always figured that tidally locked planets weren't very good. You could forget the red dwarfs, but that's wrong. It was too naive. What would actually happen is if there's some atmosphere, you'll get big winds carrying some of the heat from the hot side to the dark side. So this is actually a computer model, but you can see the temperatures, which may be in centigrade, may even be in Fahrenheit, but who cares? You notice that around the edges here, there's this belt between the light and the dark side where the temperatures are the same as in, Richardson, Texas, or whatever, okay? So they could be inhabited, even if they're tidally locked, still habitable. We don't know whether Kepler 186f, by the way, is tidally locked or not. There are reasons to think it might not be, but that would justify the NASA artist impression here on the left. But for equal time, I made my own artist impression here in my garage, actually. This is a photo in my garage. And here it's tidally locked, and you can see there's a region here where it's okay. By the way, also, I think, I put a picture here of Elisa Quintana, who's a colleague at the SETI Institute, and she's the first person on this paper. She's the one that made the discovery. Extraordinarily lovely person. And they're out looking for more. And frankly, if you want to make an easy $5, probably the best thing to do is bet somebody that they'll find more, because I think they will. Okay, let me just finish up on these red dwarfs a little bit by why they might be superior targets to look for ET. To begin with, 3/4 of all stars are red dwarfs. And that means if you can only look at some finite number, like 1,000 of them, well, on average, they're going to be a factor of 2 closer to you than if you look at stars like the sun, right? Just because there's so many more of them, okay? So a factor 2 closer in distance means they're a factor 4 stronger in the radio. They'd be easier to find. I've already said that a lot of them seem to look like good candidates for having Earth-like worlds. And the other thing about a red dwarf is they don't burn out very quickly, right? I mean, it's true, they're small, so they don't have a whole lot of fuel, but they're like VW Beetles. They don't have a lot of fuel, the tanks aren't big, but the engines are also small. Okay, so they go a long way on that fuel tank. And the same with the red dwarfs. They go for 100 billion years typically before they burn out. The sun has only got another 5 billion years to go before things get really bad. Okay, so, sell your real estate investments before that. 100 billion years, that means every red dwarf ever created in the cosmos is still burning today, isn't even a teenager yet. Well, maybe it's a teenager. Okay, so that's good, because that means on average they're older by billions of years. Just a random sample, they'll be on average billions of years older than a star like the sun. And this is the only instance I can think of where being older is actually better. Because if you're older, maybe you've had more time to not only cook up some life, but maybe cook up some intelligent life. Okay. So I think we ought to look at these. Here's another approach where I'm going to forget that approach. Forget that approach. Let's just, I know you're getting anxious and antsy. But here's Frank again. Frank comes into the office every day. He writes this equation on the board. We don't know what it means. But Frank, when I first joined the SETI Institute, I was paying attention to what people were asking Frank. And they would ask him, okay, Frank, so when are we going to find ET? And I thought he would say, well, I mean, nobody knows. But he didn't say that. He had an answer. He said, in a few years, we will. Okay. And then I listened to they would ask the same question to Jill Tarter, and she had an answer. Everybody had an answer. And I kind of noticed that the answers kind of correlated well with the number of years until they were going to retire. So I thought, well, maybe that's not a very good answer. There might be a better answer. Here's my answer. What you're trying to do is predict when you're going to find a needle in a haystack, right? Because that's what we're doing. We're looking for needles in a haystack. Now, if somebody actually gave you that problem, find a needle in a haystack, when are you going to find the needle in the haystack, Ralph? Well, Ralph might say, well, look, it depends on only 3 things. How big is the haystack? How fast am I going through the hay? And how many needles are in there anyway? Okay. Now, in the case of SETI, we know how big the haystack is. It's just our galaxy. We're looking in our galaxy. Okay, we know that. How fast are we going through the hay? How fast are we searching these stars? That's this plot. And you can see that it's getting faster all the time. Right? This is just some index of the speed of SETI searches as a function of time. So it's going up, and for the three of you who are still conscious, you may notice that it's going up exponentially, actually, exponentially. So it's in fact following Moore's law, because a lot of this is dependent on digital technology. Now, the SETI Institute is located in the heart of the Silicon Valley. I think it's the only organ that the Silicon Valley has is a heart. They never talk about it. It's the pancreas of the Silicon Valley. Okay, anyhow, it's just following the development of computer technology. Right, so that tells you how fast you're going through the hay. And it's getting faster all the time. Whatever you're doing this year is probably collecting as much data as all the previous years put together. Okay. Now, this depends a little bit on funding and other things, but roughly speaking. So the only thing that remains is to make some estimate of how many needles are in the haystack. And we don't know that. But this shows you how much of the haystack we've looked at, this line here. And these numbers on the bottom indicate estimates, well, really, they're guesses, as to how many needles might be in there. Now, that first guess, n equals 10 to the 6, a million civilizations, that's what Carl Sagan would say. I figure there are probably 1 million societies in the galaxy that are broadcasting signals that are going through your bodies as you suffer through this soporific presentation. So, if he's right, we're going to find ET very quickly. Isaac Asimov figured 100,000, which means it'll take till the mid-2020s. Frank Drake himself figures 10,000. He's very conservative. Okay. Frank's a very bright guy, and if he says 10,000, I always listen to what Frank says, because I found that he's almost always right about things. But even if his more conservative estimate is correct, then we're going to find ET, before a lot of you reach middle age, at least the younger guys. Okay. So some of the others won't be true, but okay. Okay, so that's why I figure, this horse has just as much chance of crossing the finish line as those other two horses in terms of finding life. And that this is a headline you may read, that we picked up a signal that proves that you're not the only kid on the block. Okay, now, this is my bet, and I usually bet people a cup of coffee that this will be true. All right, so let me switch gears a little bit, having told you a little bit about the experiment. What happens if we actually pick up a signal? Now, this is the Hollywood version of what happens. Anybody recognize this movie? Well, shout it out. Don't just say yes. I can't tell whether that's true or not. The Arrival. The sign of an ill-spent youth. Right. This was actually a pretty good film. It had the bad luck to come out just a few weeks before Independence Day, which had better special effects. There you see Charlie Sheen, always a great guy to see. And he'd done this experiment with his lab assistant there in Hollywood, where they wired a whole bunch of antennas together trying to pick up a signal. And they're sitting there looking bored one moment, and the next moment they're doing this. They're getting all excited. Okay, that's what Hollywood pictures will happen. That it's nothing, 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 and then suddenly, wow, we found something. That's not the way it happens. We know, because we've had false alarms. This is 3:30 in the morning at the SETI Institute in 1997, when we picked up a signal that we thought was pretty good. And my boss, sitting there in the back in the white shirt, actually called me up at home and he said, Seth, maybe you ought to come down here because, And we were all looking at these computer screens because we'd picked up this signal. Now, picking up a signal is not a rare event. You pick up signals every 10 seconds. But this one was succeeded in passing all the tests, all the automated tests that we do to try and verify, is this really ET or is it just, AT&T or something, right? That kind of thing. So this was looking good. It was 3:30 in the morning. Nobody had gone out to get a hamburger. Nobody had had any sleep. And I was so nervous because I realized this is going to ruin my whole week if we find ET. But, I was so nervous, I just walked around, taking pictures like this one. It's one of my pictures. Now, what happened? Did the government go nuts? Did they send the men in black? Did some government agents call up and say, we're going to shut you down? So many people believe that. They think the government would shut you down. And I always say, why? Why would they shut it down? This is interesting news. They say, because the public couldn't handle it. The public would go nonlinear. Well, I ask you, right, if you were to hear on the news tomorrow morning, hey, scientists find signal coming from 847 light years away, would you say, that's it, Marge? They found ET. I'm not going to work today. I'm just going to ride in the streets. Now, some of you aren't laughing, but guess you're the ones that would go. All right. But nobody was interested. I tell you quite honestly, nobody called up. And there's no secrecy. Everybody's writing emails to their friends. Today they'd be on their blogs, and so forth. Everybody knew about it. And I kept waiting for somebody to show some interest, even the mayor of Mountain View, whom I knew. And he didn't even call up. Nobody called up. My mom didn't call up. Nobody called up until 6 hours after I made this photo. I was half asleep at my desk, and the phone finally did ring, and it was the New York Times. And they already knew about it, and they wanted to write a story about it. And I said, well, we have to check it out. Can I call you back in a couple of hours? Which I did, by which point some of these people had figured out that it was just interference from a science research satellite, the SOHO satellite. The signals were bouncing around the steelwork of our antenna just in the right way to fool us. Okay, but this proved that there's no secrecy to begin with, and that, nobody was going to try and keep this quiet. So all of that. The public expects this, yeah. That would be really fun. I figure if the government could afford to pay these guys, could afford to support SETI a little bit. Okay. All right, it's goofy. By the way, another reason to think that the public would go crazy being goofy, there is historical precedent for this. Here are some newspaper articles from 100 years ago. And you see there Percival Lowell, a guy who built the observatory in Flagstaff, actually. Percival Lowell is a very clever guy. He got a degree in mathematics from Harvard. He was said to be the smartest student that ever went to Harvard, but, it's only Harvard, I guess, but I don't know, whatever. And he claimed that there were these canals, crisscrossing the surface of Mars. He absolutely did believe this. Until the day he died in 1916, he was quite convinced of this. Other astronomers became less and less convinced as time went on. But anyhow, his point was there was this vast hydraulic society just 35 million miles from downtown Houston. And people weren't going nuts. They just thought it was interesting, right? They just thought it was interesting. So the idea that we would, get upset about a radio signal coming, 100,000 times farther away, coming and being picked up, I think doesn't make any sense. Here's a more recent example. This is 1996. The biggest science news story of 1996, the Martian meteorite ALH 84001. And several of the people involved with this story actually were here in Houston, NASA. And they opened up this meteorite. This meteorite is known to come from Mars. That's not controversial. There are like 30 or 40 meteorites that we've picked up that we know come from Mars. And you may wonder how, but Chris McKay at the NASA Ames tells me that there's a brass plate on the bottom that says made on Mars. But probably not true. But certainly on the basis of compositional evidence, we know this came from Mars. But the thing was that they opened it up and they found things inside, like a little Rodney here, that were claimed to be fossilized microbes. Several of the people involved in this line of research still give it credibility. Most of the astrobiology community is fairly skeptical. So consider this an unproven case. But again, this was, and for 4 days, maybe it was only 3, it was in headlines in the New York Times that were big enough to read from low-flying aircraft. These were very big headlines. Okay, but the public didn't go crazy. They just thought, that's interesting. That's interesting. Okay. Now, what about religious belief? This is a question that I get frequently. How would it affect religions to find for sure that there's somebody out there? And in particular, if we're picking up their signal, then they're more advanced than we are, at least in a technical sense. So how would that make you feel? How would that make religion feel? Here you see Galileo having troubles with the church because he was claiming that, well, that's the end of Galileo. Yeah. Did that help? It did. He's back. Okay. Yeah. Do you see Galileo? He's the guy that looks like Galileo in this painting. All right. So, there is some precedent for this being a disruptive idea to say that you're not as special as you've always been told. But on the other hand, here's Brother Guy Consolmagno, and he works at the Vatican Observatory, and I'll read a little bit of this since it's hard for everyone to read the text, but he says that the theologians would be fascinated because it would provoke many interesting theological discussions. Well, no doubt about that. But if your religion has survived millennia, if it can handle Copernicus, Galileo, even Darwin, then E.T. should eventually prove palatable. Guy Consolmagno is he's very keen on the idea of looking for life elsewhere in the universe, intelligent life. Now, here's a different view, and this is from sociologist Bill Bainbridge, who thinks that yes, mainstream religions would have no trouble accepting the idea of not just life elsewhere, but intelligent life. He thinks that that wouldn't be true for fundamentalists. And his prediction is that the fundamentalists would get upset, become angry, feel beleaguered. They'd begin to snipe at science in a broader context and maybe argue this is all a hoax, similar to what we see happening with global warming. Okay, so he says that you shouldn't underestimate this point of view because, and I thought this was a very interesting comment. He said, whenever scientists talk to theologians, they speak to scholars at the Harvard Divinity School, not to the people who represent the real believers. And those would say, no, that signal isn't actually from extraterrestrials, it's Satan tempting you. So that's Bainbridge's point of view. I don't know what the real answer is. If there are any students of anthropology, social science in the audience, you know, are looking for a PhD topic, this is completely unexplored territory. Nobody knows what would really happen. And I think it would be interesting to know. Everybody wants to know. And one final, well, almost final, unfortunately for you, thought is this. Here you see Stephen Hawking. There is the question of, if you pick up a signal, should you respond to that? Should you say anything back, right? And he's saying, don't do it. It's like shouting in the jungle, right? You don't know what's out there. Maybe 99% of them are friendly, but if 1% of them are not friendly, you know, you may just provoke an attack. They'll come and incinerate the planet, and then your tombstone will read, responsible for the end of humanity or the world or something, which would be a bummer. So, and it's hard to argue with that because nobody knows what the aliens are like. Nobody knows whether they'd be friendly or not. And maybe 1% of them would be hostile. You don't know. So maybe we shouldn't broadcast. Well, that would see, it'd ruin your whole day. Okay. I think this is nonsense, by the way. I'm going to make this quick plea that this is nonsense because I think it's very easy to show that any society that could actually threaten Earth from hundreds of light years, if they had the technology to launch interstellar battle wagons that would come here and, you know, ruin your whole day by boiling away the planet, they can already learn that you're here. They can pick up our leakage. And we're building bigger telescopes all the time, as you can see in this graphic. Here's some big ones now under construction. We're increasing the size of our telescopes by roughly a factor of 100 every century, right? So if the aliens are only a couple of centuries ahead of us, they can pick up television, FM radio, radar, all that stuff that's been leaking off this planet since the Second World War, right? And they have to be at least that advanced, otherwise they're no threat. They can't get here. They probably can't get here anyway, but, you know, even being optimistic about that. I think there's no point in worrying about this. If you have a dental appointment next week, you can worry about that, but don't worry about this because it's too late. That horse has left the barn, okay? There it goes. Okay. So, and by the way, and this to me is actually the really important part of this whole argument. Mind you, I have to warn you, there are plenty of people who disagree with me on this, and you may, but this to me is the worst part of this. If you say we're going to circumscribe transmissions from Earth because they might be dangerous, you can't just do that for the weekend, or this month, or this year. You have to do it forever. Right? You have to do it forever. And that means there are all sorts of future activities that our descendants will not be able to do because they make noise that could be picked up. I've been putting power sats in orbit and things like that that might really solve the energy problem. All those would be, so this is really a constraint on all future generations if we try and do this. And beside, do you really want them to turn off the radars at the airport in Houston? I mean, do you really want that? I bet you don't. I don't. Okay. Finally, what might the aliens be like? I was telling my dinner companions tonight about how I occasionally consult for movies. And one of the questions that the writers always ask is, so what will the aliens be like? Right? Like we know, but, you know, they figure I know better than they do. And they kind of assume they're going to be like these guys, you know, the little gray guys, because those are your standard ASA standard, ISO standard aliens these days. Mind you, a biologist pointed out to me, Laurie Marino pointed out to me that these are merely representations of what we think we will become, right? Maybe 1 million years from now, when we've lost all the rest of our hair and our teeth have all gone away and when noses are smaller. The only thing that have gotten bigger are the eyes because, you know, our future progeny will spend all their time designing websites, whatever it is. So that's us. It's not necessarily them, that's us, okay? Now here's somebody else's idea. this actually appeared. This was a projection by somebody in the social sciences about the future evolution of humans. You notice they don't show the thumbs. I would like to see the thumbs. I think it would be very small and nimble. Okay. But all you can really say about what the aliens would be like is this. They have to be intelligent. Not all aliens are going to be intelligent. There are probably plenty of aliens that are not intelligent. There are probably lots of aliens that are no smarter than a trilobite, right? Or a bacterium. But you're not going to hear from those guys. Those aren't the guys that are going to build a radio transmitter. To be intelligent, our definition of intelligence is you can build a radio transmitter, like David Sarnoff here. Okay, build a radio transmitter. So, nudge the guy sitting next to you. Hey, can you build a radio transmitter? You'll know whether you ought to carpool with him anymore. Okay, that's our definition. Now, what does it take to build a radio transmitter? You have to have a brain. And those of you who weighed your brain this morning know that it weighs about 3 pounds. That's 2% of your body weight. But it takes 25 watts to run your brain. Now, you may not have thought of it that way, but your whole body is only like 75 watts, right? That means, 1/3, 1/4 of all the calories you had at Sonic tonight go just to heat your brain, which is only, 2% of your body weight. It's very expensive metabolically to have that big brain. That's why most other animals have sort of opted out on that. Okay, so it's very expensive. 25 watts, that's your brain. It's the same power as a fridge light. A fact that might be useful in your next cocktail party. I never really thought about it that way. But okay, let me just show you this. This is plot number 11. This plot showing the size of your brain over the last 3 million years. Okay, 3 million years ago, your brain weighed ½ kilo, 1 pound. A million years ago, of course, you were just some sort of a simian there. A million years ago, still a simian, your brain weighed 2 pounds. Today, your brain weighs 3 pounds. Now, that step from 2 pounds to 3 pounds was important because if you have a 2-pound brain, you're a forest ape. If you have a 3-pound brain, you get tenure next door, okay? So this is tempting because it looks like, well, in the future, we'll just keep going up there, right? And eventually, we'll have 10-pound brains. And that's what we should expect from ET. They're just these big-headed guys. Right? Now, it's unclear that that's going to happen for us because I think women will go on strike if they have to give birth to babies that have giant heads. Whatever. I don't know. I think that no matter what you think of the future trend of Darwinian evolution, it seems to be somewhat unpredictable up until now. But we may be changing that in this century. But I think we're changing something else that's more important than even biological engineering, which is probably coming down the pike. This is a plot from Hans Moravich at Carnegie Mellon, in which he's plotted the amount of compute power you can buy for $1,000 since 1900. And of course, it's going up. And although it's lost over here on the left side of the screen, it's going up exponentially. Now, the data here end in 2007, but those of you can see by 2020, your laptop will have the same compute power as a human brain. It already has more memory than a human brain, more or less. Okay. So by 2020, the hardware in your laptop is sort of comparable to the hardware in your cranium. Now, that doesn't mean it can think, but making something that can think is, again, something that we will probably do in the 21st century. If you talk to people in the artificial intelligence world and you say, do you think by mid-century we'll have machines that can write the great American novel or teach astrophysics at Rice or whatever, right? The answer I usually give from these guys is yes. That's it. That's all they say. Okay. Now, they've been saying this for a long time, and they've been wrong so far, but one of these days they may be right. So the point is, this is a time scale argument. Here you see Marconi in 1900 with practical radio. In less than half a century, we already had computers. I mean, they were big and, whatever, but the ideas were all there, okay? Well, sometime in this century, it looks like we may, in fact, invent our successors. Maybe it's not 2050, maybe it takes 2100, 2150, doesn't matter. All those numbers are the same number. The point is, you invent radio, you go on the air, and within a few hundred years, you've invented synthetic intelligence. And the big advantage of synthetic intelligence is that it can evolve much, much more rapidly than biology can, right? Comparison. Here on the left, a history of a horse. You see a horse 60 million years ago was the size of a collie dog. Today, a horse is the size of a horse. Okay, so that's 60 million years of Darwin, right? On the right, personal computers. I had one in 1977. Here's one from 1974. The one I have today at home is 10,000 times better than the one I had 35 years ago. Factor of 10,000 times better in 35 years. Compare that to the horse, right? Much, much faster. The first thing that happens if you build a thinking machine is you ask it hey, design something better than you are. And then you build that. Design something better than you are. Then you build that. It can improve very rapidly. Okay. So, and you may be sitting there wondering, well, what happens to us? I think that's a good question. I do not have an answer. But some people think we'll be turned into these pets. But I think the bottom line is this, and it's something that you might want to keep in mind. I've sort of suggested that we may actually pick up a signal that would tell us that somebody's out there within the next, I'd say 20 years. Could be wrong, but let's say if it's not 20 years, maybe 50 years. But I think that'll happen. And if you ask what's behind the microphone, don't count on it being one of these little gray guys with the big eyeballs, no hair, no clothes, and no sense of humor. It's going to be a machine. I think it's very likely to be a machine. Okay, I'm going to stop here and give you the opportunity to ask some questions. Particularly the people in the overflow room those that are not asleep back there.
And we'll get to them in a second. So I'm glad I went with him last because the rest of the series would have been a major disappointment. Not that they were bad. They were great talks, but that was fabulous. All right, so now it's time for Q&A like we typically do. We'll do 2 in here, 2 over the overflow, and then come back in here and back and forth for, well, not for a long time. Yeah. All right, so let's start in here. We'll take 2 questions in here. Over here.
Astronomers are always talking about finding planets with sun-like stars. Well, what do they mean by sunlight? To me, it's F5 to K5, and everything else is not sunlight. What do y'all mean?
Yeah, I don't think it's that well defined. There's some range of stellar types, as you imply. What does it mean to be a sun-like star? It means, of course, more or less the same size, diameter, and luminosity as the sun. You know, stars are kind of like cats. If you've seen one, you've seen them all, right? I mean, the difference between the tabby you have at home and a tiger or lion is just a matter of scale. But otherwise, it's pretty much the same, okay? And it's the same with stars. They scale very simply. So indeed, it's a range of sizes and brightness that is fairly poorly defined, but the sun, as you know, is a G-type star, so you might say G-type stars are sun-like. It's size and brightness. It's you know, if you're going to put a number down in a book, then you have to specify over what range of spectral types you're calling it sun-like. I don't know that there's any, I must say I'm not a stellar astronomer, but I don't think that there's actually one definition that everybody has always used.
Given all the likelihoods you've quoted of how likely it is that there are other beings out there, perhaps even intelligent beings, isn't it much more likely that one of them are going to find us before we find them?
Yeah, that's a good question. Is it more likely that the aliens will find us before we find them? And you might say that sounds reasonable because they probably have much better equipment than we do, at least some of them. That sounds pretty convincing. And I would agree that that's a perfectly reasonable suggestion, except for this. Finding Earth is not so hard, but finding Homo sapiens is hard. How can you find us? This is something to consider if you're one of the 1/3 of Americans who think we're being visited. I always wonder, why are they visiting just now, just in time to improve your social life, right? It's a real question, because that suggests that they know we're here, and therefore they're interested in us, and they're always interested in us, right? And yet the evidence for your presence is almost impossible to find from any great distance. I mean, they can't find the interstates, right? They can't find your house. They can't find anything except the radio emissions. And high-frequency, high-powered radio emissions have been in activity since, as I say, more or less the Second World War. So those transmissions are only, 70, 75 light years out. The number of stars within that distance isn't terribly large, it's a few thousand. Okay, so I think it's very likely that nobody knows we're here. Nobody knows we're here yet. If you wait a couple of thousand years, then here's a number for you. Those leakage transmissions are washing over a new star system at the rate of about 1 a day, but that picks up with time. So eventually, a large fraction of the cosmos will know we're here, or at least a large fraction of the nearby galaxy. At the moment, I don't think they know we're here, and they may not be spending a whole lot of time trying to prove that we are, and they would have a hard time doing that. He has a retort. You should maybe a chemist.
That's good. I think it would be more likely than that scenario that they know we're here, but there's so many other more interesting places that we're low on their list.
Yeah, the gentleman suggests that they might know we're here, but that we're not interesting enough. There are other civilizations that are more interesting. We're low on the list. That's, yeah, this unfortunately is this is a speculation in the area of alien sociology. I have to tell you, the data set for alien sociology is sparse.
All right, overflow room. We have any questions over there?
No, that's not the way it worked. That signal was actually picked up when we were using an antenna, the 140-foot antenna, as it's called. Astronomers are very unimaginative when it comes to naming their telescopes. The 140-foot antenna in Greenbank, West Virginia. Jill Tarter was there, one of my colleagues, and several others. Certainly, at any given time when we're observing, usually there's several people at the telescope. These days, we don't go to the telescope at all. It's all done automatically. But in those days, there would have been 3-5 people. And there was even a TV crew there, right? So they got very excited, as you can imagine. Hey, we're here just in time to see the big discovery. Okay, and it turned out not to be the big discovery, but they still took some video footage. So it wasn't just one person. And immediately, of course, those data are also sent, they were being sent back to California, where I was and the people you saw in my photo. And we were looking at the same thing that they were looking at in West Virginia.
Another one overflow? One more? Okay. We'll come back here.
Hi, so I have a question in regards to the 3 horses. So you said the big money is going to the first 2. What would happen if more money came to SETI? How would that be spent? Because you're not sending spacecraft out to observe the atmospheres. If a bigger chunk of money came to SETI, what would it be used towards?
Yeah, if more money came to SETI. Good question, Annie. And I hope you're going to write a check later. Let me give you some numbers on. I mean, to send a mission to Mars, as you know, costs hundreds of millions. Many of you may be in the business of doing this, so you know what the costs are. And there are various classes of missions, and they vary from a couple of $100 million, for example, up to the Kepler telescope costs, I don't know, 300 million or something like that. And some of the Mars missions might cost billions of dollars. They can. Okay. SETI runs on about, even in the days of the NASA SETI, and those ended 21 years ago, at maximum it was 3 cents per taxpayer per year, was $10 million a year. But now the SETI Institute SETI programs are